All right, everybody, this is going to be section 1.4, polygons. So we're going to go over all the basic terms about polygons and how to name and compare the different types of polygons. So what is the actual definition of a polygon? A polygon is going to be a closed figure, okay, formed by or in a plane, okay, or on a plane formed by 3 or more segments, okay? So a closed figure in a plane formed by 3 or more segments connecting at their endpoints. So this gets formal when it goes back to all those basic terms, points and segments. Each segment is going to be represented as a side, which y'all probably knew that, and each endpoint connecting the two sides is called the vertex. So here are about 4 examples of polygons. Okay, they're all made up of segments and they all meet at each endpoint. So you've got points right here. That one's the smallest polygon. So there's all sorts of polygons here. Okay, and they all join at the endpoints. Okay, so these are all different types of polygons. These are examples that are not polygons. You can clearly see a lot of these are curved. So anything that's curved, okay, is not going to be a polygon. This one is close to being a polygon, but it's not closed. And then this one is kind of like 2 separate polygons, but I think what they were thinking is 1 side, 2, 3, and 4. So in other words, the sides cannot intersect, okay? But if you were to consider this as a polygon, that would be correct, okay? Polygon parts. So the polygon parts, you'll hear the teacher say different part names that you'll need to recognize, okay? And you may have heard of these before in the past, but just make sure you know what we're talking about when your teacher calls out these particular vocabulary words, okay? So over here, point D, that would be considered a vertex, okay? So when you want to talk about more than one, you would say vertices, okay? So these two, A and E, those 2 angles are considered consecutive vertices because they're right next to each other. Okay, remember consecutive is one right after the other. Okay, and then we kind of said this a second ago, this is a side. So a segment is represented as a side. So this has 1, 2, 3, 4, 5 sides. And then these 2 would be consecutive sides because they're 2 sides right next to each other. So they both share a vertex. Okay, so side DC and side BC are consecutive sides. Okay, so we've been naming a lot of things in geometry, so you also can name a polygon. The way you would name this particular polygon is pentagon ABCD, okay? You don't necessarily need to add the word pentagon in front, but you do need to put those in order, okay? And they got to be in consecutive order, just like we said, we wrote up here, name or list the vertices in consecutive order. Now, let's say you start off with D, okay? That is fine. Just make sure you go in consecutive order. So you could say D, C, B, A, E. So polygon DCBA, E is another way to name that polygon. So you can start with whatever letter you want. You can even go in reverse order. You could say D, E, A, B, C. Okay, so as long as you start with a letter, a vertex, and then go in consecutive order. We're going to have to be able to classify the different polygons. So we're going to go over these names. A lot of these you know. Okay, so we're just going to review those. So if it's a polygon that has 3 sides, that's known as a triangle. 4 sides is a quadrilateral. I know a lot of y'all are probably thinking square and rectangle. Those are special types of quadrilaterals. So when we just refer to a 4-sided figure in general, you're going to say quadrilateral. We have pentagon that has 5 sides, hexagon 6, heptagon 7. I think another way to say that is septagon too, so both of those would be fine. 8 is octagon, 9 is nonagon, 10 is decagon, 11 is ondecagon or undecagon, 12 is dodecagon, and then 13, we can just go ahead and say 13gon. I know there's probably some specific names, but once we get beyond past 12, we can just use the actual number. And then n is ngon for any number of sides, anywhere from 3 to a very large number, okay? So those are all the names. Feel free to pause it and write them all down, okay? Because we may refer to those and you got to know how many sides each one represents. I would say the one that is most difficult to remember, and I'll put little stars next to them, is the 11-sided figure, the 12-sided figure, maybe even the 9-sided figure. It's not ninagon, it's nonagon. Oh, and the 7. Okay, so just make sure you study those. What is a diagonal? A diagonal is a line segment that connects two non-consecutive vertices of a polygon. So we always want to draw pictures. So here's an example. So in this pentagon, you see how we're connecting this vertex and this vertex. They're not right next to each other. That's what you call a non-consecutive vertices. So those two, as you connect them, that would be a diagonal. Okay, there's actually more diagonals that you can make in here. So we can have that one. We can have that one. Here's another one. And one more. So those are 1, 2, 3, 4, 5 diagonals exist in the pentagon. Okay, so diagonals can be in any kind of shape. So even a concave polygon. Okay, so if I have a concave polygon, which I talk about in the future, so I guess I'll go over that then. So convex polygon. This is a polygon that has no diagonals outside of the polygon. Okay, so write that down. There's no diagonals outside of the polygon. So here's an example of convex polygons. I have 4 different polygons, okay, and they all have purple diagonals inside. And so you can see they clearly cannot end up outside of the polygon. So on the next slide, you'll see what I mean as far as polygons outside of the, diagonals outside of the polygon. And that would be the concave polygon that I kind of mentioned earlier. So this is going to be a polygon in which at least one diagonal can be constructed outside of the polygon. So here are some examples of some concave polygons. So they're all, they're in black, and the orange segments are representing the diagonals, because I know it can get a little confusing. So you have polygon, let's see, this polygon right here, that's blue. So if you have that polygon and it's caving in right there, you see that? And that's why this orange diagonal is in the exterior, okay? The star is the one that mostly everybody knows to be a concave polygon, okay? Because it caves in like 5 times, right there, there, and there, okay? So when it caves in, that's when you can draw those orange diagonals outside of the polygon, okay? Now, let me go back about drawing diagonals. Diagonals exist as long as you connect non-consecutive vertices. So for instance, in this one here, in the middle, you have 2 diagonals that are in the exterior. That doesn't mean this polygon only has 2 diagonals. We have another diagonal here. We have another diagonal here. We have one here. We have one, which one else am I missing right here? Okay. We have this one here. We have this one there. that one there. And make sure I got all of them. Yeah, so those are all the diagonals there. Okay, so they exist inside and outside of the polygon. So sometimes it asks how many diagonals exist in a polygon. Well, you need to draw all of them out, okay? So this one here has 1, 2, 3, 4, 5, 6, 7, 8. Let me highlight them because sometimes it gets difficult on counting these. So this concave polygon has 1, 2, 3, 4, 5, 6, 7, 8. Yes, so I was right. 8. Oh, wait, 9. I forgot that one right there. There's 9 diagonals in this concave. What kind of polygon is this? It has 1, 2, 3, 4, 5, 6. Concave hexagon. Okay, has 9 diagonals. Let me make sure I got all of them. 1, 2, 3. 1, 2, 3. Yes. Okay. All right, just to recall perimeter, most of y'all know this is super easy. Perimeter just means you add each side of the polygon. So you add all the segments that enclose the figure. Okay, so 15 plus 5 plus 6 plus 12, we've got 38 centimeters. You want to add the sum of the side lengths. Equilateral polygon, okay, what is an equilateral polygon? An equilateral polygon has all sides congruent. So all sides are congruent. That's why you see all those tick marks. Equal angular polygon has all angles congruent. And then if we were to put those two together, that means they have all sides and angles congruent, and that's referred to as a regular polygon. That's the one a lot of kids tend to forget, so make sure you study that one. Regular polygon. Congruent polygons is the word congruent again. Remember, it represents polygons that are the exact shape and the exact same size. Okay, all corresponding sides and angles must be congruent. Okay, that's what declares for a congruent polygon. And so here you have polygon CAMP being congruent to polygon CITE. So let's take a look at what type of polygons we have here. Here's one, and here's the other. Okay, so you can clearly see every side and every angle is congruent. And that's what determines congruent polygons. And that is it. Oh, one thing that I want to mention is you always want to make sure, let me get my pen, you always want to make sure you write the letters in corresponding order. So for instance, you wrote C first. Well, angle C is right here and it has 4 tick marks. You better make sure that it matches up with S because they have to be in corresponding order. So let's look at S, and that has the 4 tick marks there. So that's correct. Same thing goes for A. A must correspond to I. So if you look at A has 3 and I has the 3 as well. And then M, want to make sure that corresponds to T. M is with T. And lastly, P with E. E has to correspond with E. P1, and so obviously it would be the last one. And then you'll also notice that these segments are congruent. CA would be congruent to SI because those are the first two. All right, so everything corresponds perfectly when we're talking about congruent polygons.